Hello, everyone. For machine learning engineer position at OpenTable. In this interview, we will ask several questions related to machine learning systems, recommendation system, and its production deployment. Let's begin the interview. To start, could you introduce yourself?
Sure. Hello, my name is Heng Liang, and I am a Master of Engineering student in Systems and Technology at McMaster University. My background is mainly in machine learning systems and backend engineering. I have worked on several projects involving large language models, retrieval systems, and production AI pipelines. For example, I built a retrieval augmented generation system for a medical question answering platform. Well, I designed the full pipeline, including documents processing, hybrid retrieval, re-ranking, and answer generation. I am interested in building AI-powered search and recommendation systems, which is why the machine learning engineer role at OpenTable is very exciting to me. I enjoy working on systems that combine machine learning models with scalable production infrastructure to solve real-world problems.
Thanks for the introduction. Could you tell us about the machine learning system that you built and deployed end-to-end?
Yes, of course. In one of my recent projects, I developed a retrieval augmented generation system, or RAG system, for medical question answering application. The goal of the system was to help users retrieve reliable medical information from a structured knowledge base. First, I processed the large medical datasets and converted it into structured documents. Then I implemented a hybrid retrieval pipeline combining BM25 lexical search and dense vector embeddings stored in a vector database. This allowed the system to retrieve relevant documents for each user query. After retrieving candidates' documents, I added a re-ranking model based on transformer architectures to improve retrieval precision. Finally, a large language model generated answers using the retrieved documents as contextual evidence. To make the system usable in real-world environments, I deployed the backend using fast API and Docker containers, which allowed scalable API services and simplified deployment. Through evaluation, I used a constructed test set. The system achieved over 90% accuracy in retrieving relevant answers. This project helps me understand how to build machine learning systems that integrates retrieval, re-ranking, and generation in production environments.
Oh, that's an interesting project. And OpenTable focuses on helping diners discover restaurants. How would you design a recommendation system for restaurant discovery?
If I were designing a restaurant's recommendation system, I would start by combining user behavior data, restaurants metadata, and machine learning models. First, I would collect relevant signals such as user reservation history, search behavior, geographic location, and restaurants attributes like ratings or price range. Next, I would implement a candidate generation stage using collaborative filtering or embedding-based retrieval models to retrieve a set of potentially relevant restaurants. After generating candidates, I would apply a ranking model to reorder the restaurants according to relevance. The ranking model could use gradients boosting or neural networks to incorporate multiple signals such as the distance, popularity, and user preferences. Finally, the system would be deployed as scalable microservices, and its performance would be improved through A/B testing experiments. Metrics such as click-through rates and reservation conversation rates would be monitored to evaluate the effectiveness of the recommendation system.
How do you ensure machine learning models perform well in production environments?
Ensuring machine learning model performance in production requires several important practices. First, I would define clear evaluation metrics depending on the application, such as accuracy, recall, or business-related metrics. Second, I would implement monitoring systems to track model predictions and detect issues such as data drift or distribution changes. Third, I would design automatic retraining pipelines that update models with new data so that they remain aligned with evolving using behavior. Finally, I would use A/B testing frameworks to safely evaluate new model versions before full deployment. These practices help ensure that machine learning systems remain reliable, maintain performance over time, and deliver meaningful value in production environments.
Thank you for your answers. This concludes our mock interview demonstration for the machine learning engineer position at OpenTable. Thank you for watching.